So who had experience back in the day with like T1, T3, DS1, DS3 circuits? Who did, frame structure on, those super frames and all of that stuff? Anybody? I was a WAN geek. I loved that type of stuff. Very similar here. We've got a frame structure that gets scheduled, and what you're seeing is the TDD frame structure. So again, we have to interleave uplink and downlink. So one frame is 10 milliseconds long, and a subframe then is 1 millisecond. So what we break down then is we break a frame down into subframes, and we schedule uplink or downlink for every subframe, or there's also a special subframe which are more like your pilot signals for sync and control information. So unlike Wi-Fi, we don't have broadcast information like beacons and probes and things like that. Everything happens in a controlled channel in the special subframe. So it's very well defined how often these go out, and they don't really grow or shrink like they do in Wi-Fi with, let's say, how many SSIDs you have or something like that.
So they're always time-based and never size-based?
They are, we'll get into that, time-based and size-based. We'll work to it, right? So just know from a scheduling perspective then, that's how it's laid out. 10 milliseconds broken down into 1 millisecond subframes, and each 1 millisecond is either uplink or downlink. And this is the frame configuration. So of those 10 subframes, there are different configurations for how much you want to weight uplink versus downlink. And you can see 7 of them here. And CBRS supports specifically 2 of them. So this is where, LTE has a lot in the spec. CBRS supports a subset of the capabilities. So CBRS supports config 1 and config 2. Config 1 is a ratio a little bit more for, well, it's weighted equally from a subframe perspective for uplink and downlink. That doesn't mean necessarily the same throughput on uplink and downlink though, and we'll get into why. And config 2 is weighted a little bit more for downlink. So you can configure either of those 2. So if you want to weight it more for downlink, you do config 2. Or if you have more uplink, you want to probably config 1. Yeah, and so really the whole basis for this is scheduling traffic so it's very predictable, and there's less latency and jitter in the environment, so you know exactly when your uplink and downlink are going to happen. Is there a concept of retransmissions? Yes. So if data doesn't get through, there's still an acknowledgement process. I don't have it in this deck, but if you want to look it up, it's called H-ARQ, H-ARQ. And it's kind of similar to BlockAC, but it's a little bit more granular than that actually. There's actually very specific sections of a packet that may need to be retransmitted, and it can signal that. OFDMA frame structure in LTE. Well, let me back up a second. So is there any questions on frame configurations? Because this is pretty important. The question is it set statically? Yes, it's set statically and configured on a radio by radio basis, but you would want all of the radios in any given environment or site to be consistent. That becomes important for frequency reuse and interference coordination. We'll get into frequency reuse and interference in a little bit, but just know that you want all the radios probably to be the same config in a given site. Any other questions? Okay. Frame structure for OFDMA. So who is pretty familiar with Wi-Fi 6 and OFDMA and how that frame structure looks like with subcarriers and resource units, and a lot of people kind of somewhat? Okay. So here I've got LTE in TD fashion on the top, and I've got a comparison on the bottom with Wi-Fi 6, just so we have a comparison for a frame of reference. So you can see the frequencies are going on the y-axis, and the time is going on the x-axis. So we have the smallest unit that you can schedule is called a physical resource block, and that is composed of 12 subcarriers, and for one time slot, which is half a subframe. So we had a frame 10 milliseconds, a subframe 1 millisecond, and then a time slot is a half a millisecond. A physical resource block is a time slot, and it's 12 subcarriers. And then on the right-hand side there, you can see how many physical resource blocks and subcarriers make up a given carrier or channel. So a 20 megahertz channel has 100 physical resource blocks and 1,200 subcarriers within it. From a scheduling perspective, the different colors mean this is how we're scheduling different users to transmit their data. We can do that in both the frequency and the time domain. And so the comparison here, if you're familiar with Wi-Fi 6, is Wi-Fi 6 for an RU, we assign an RU means only a subset of frequency subcarriers for a frame duration. In LTE, it's both a number of subcarriers and for a given time within that frame. And then we can switch those subcarriers to a different user as well. So when you see like going left to right, you see maybe on the bottom there, you see the light green user going of the last 3 subcarriers for a period of time, and then it switches to a different user. So there's very granular frequency and time-based scheduling. And this is a lot of why, one of the reasons why you may have heard LTE is more efficient than Wi-Fi. It can pack these user transmissions in tighter. With Wi-Fi, especially prior to OFDMA, it was just single user taking up the whole channel and potentially not using the whole capabilities of the channel. Even with Wi-Fi 6, you've got individual users in RUs that take up those subcarriers for the entire duration of the frame. And depending on the length of all the different users you're packing into that frame, they may not all take the same amount of time. So if you've allocated in Wi-Fi, a certain RU size to a client, and they get done transmitting before clients in the other RUs are done, because their modulation takes longer or shorter time, you have to pad. So you can't pack them in as tight as you could on LTE.
Is there any multi-user MIMO aspect to this?
The question is there any multi-user MIMO aspect? I'm not positive on that one. That's something I haven't studied yet. Mehmet, do you want to chime in?
Yeah, I mean, MIMO is obviously there,
Yeah.
and multi-user MIMO and different variants of it is now part of 5G NR. So this evolution of it, I would say, but maybe we can take it offline. We can have more detailed discussion.
Anything else I missed? So yeah, from a scheduling perspective, the minimum block that can get scheduled is 2 PRBs or essentially 1 subframe. Yeah.
Each of those little boxes there, is that the same time?
I think it was called an element, right? So the question is each of those little boxes for scheduling purposes, like a subcarrier and a symbol, is that called a tone or is that called an element, or what is the terminology for that?
Yeah, OFDM tone is the most granular kind of unit.
Yeah,
But
so
you're absolutely right. Like for scheduling purposes, PRB is what you need.
Yeah, so would each one of those little boxes be a tone? A subcarrier for a symbol?
Yeah, OFDM symbol and a tone is the unit.
Okay, yeah, so that would be a tone. It's a good question because a lot of times you'll hear terminology of users get scheduled tones, not necessarily resource blocks or something like that. And so tones are the combination of the subcarrier and how many symbols they get. Some data rate information. So this is a little bit harder to come by in LTE because it's just a lot of different variables that go into it. So I had one of our lead radio engineers kind of help me compile this. So you can see from a modulation perspective, it supports from QPSK all the way down to 256 QAM, very similar to Wi-Fi. And the downlink, you have a coding ratio, which is, and then an efficiency ratio. Very similar, although, in Wi-Fi it's more like fractional, very defined fractionals. This is more just, granular. And then in TDD on the right-hand side, you see for a 20 megahertz channel, this would be an MCS table for a 20 megahertz channel. So you can have 10 megahertz channels in CBRS as well. So those would be different data rates, but for this size of channel, you can see your maximum data rate at highest modulation would be downlink 148 megabits or so. That's not the full channel capacity because remember we've got the frame structure and the configuration profile weighted a certain way. So this is for 2x2 MIMO with config 2, which is weighted for downlink. If you added in the uplink for TDD config 2, I'd noted it over there on the right, it would be an additional 19.5 megabits or so uplink. So that's kind of your breakout. 148 down, 19.5 up in that config profile for that channel width. And then if you did TDD config 1, you could weight it a little bit higher for uplink, and then your downlink would be a little bit less. Yeah.
So when I say 2x2 MIMO, is that typical of a client device?
Yes, the question is 2x2 MIMO typical for an eNode B in a client device? I would say yes. All the small cells that we're working with right now are 2x2 MIMO. Most of the handsets from a carrier perspective and the smartphone perspective are all based around 2x2 MIMO. Are there any plans to go for higher orders of MIMO on devices? In 5G, not in LTE? Okay. Question?
That efficiency index, what is that reference?
So just like there's an efficiency index, data to parity bits kind of. So there's a coding ratio, there's an efficiency index as well. So yeah, it's just you don't need it to compute the data rate. It's just there to show you, what the efficiency is with the coding ratio. Yeah. And the other thing then is, so I don't have uplink in a table because it gets really hairy to try to actually tell you what a specific client would support for uplink. I gave you the max for TDD config 1 and 2 over there on the right, but client devices are categorized into UE categories, and a UE category is a standardized mapping of what a client device in that category will support from a feature perspective. So when we get into UE categories, each release of the spec has support for different, adds different categories into the mix. If there's new, enhancements that come in, they define new UE categories to take advantage of those. So the UE category defines, when you see CC, it's component carriers or carrier aggregation. So just like you have wide channels, how many different component carriers for carrier aggregation would a client device support? Also, how many MIMO characteristics does it support? How many spatial streams? And what's the highest order of modulation that those devices can support? So you get all of these variances based on the UE category of what it supports and what its achievable data rates are. So it gets kind of hairy pretty quick. Release 11 and earlier, downlink and uplink UE categories were combined. So you had one UE category and it defined both its downlink and its uplink characteristics. They split after release 12 and later, and they have separate UE categories for downlink and uplink. So again, it gets fairly complex, but I just want you to know that it's out there. If you're looking at UE categories, that this is kind of what it means. So after release 12, this is an example of downlink versus uplink UE categories and what they support. So this isn't the full list. And the other thing to note is that 3GPP defines if you're this category downlink, you only can support these categories of uplink and vice versa. So there's also a defined mapping of devices which combinations are supported. I don't know the background of that, but it seems fairly intense to me. Any questions on UE categories? Yeah. What's it in terms of throughput? There's some example information on different UE categories and throughput for downlink and uplink, and then the maximum modulation supported. So unfortunately, I don't have a good data rate table for you, analogous to Wi-Fi or something like that. But I can tell you that you got to go look at the UE category that the device supports, and that will tell you what it's achievable of. So yeah, the higher numbered category is the higher capabilities. And so CBRS is supported in some of the newer categories from category 12 and later. Question?
Is that also used in the full 32 megahertz?
No, this is just generic LTE. This is not specific to CBRS, other than the line that says CBRS support.